Multiplying polynomials. Mr. Todd, why does it not say dividing polynomials? Dividing's a problem. Dividing's a problem. We'll get to it. We'll get to talking about dividing. But for now, we'll stick with adding, subtracting, and multiplying because those ones, there's no really big problems. You just have to know what the procedure is to handle these situations. You're supposed to have seen this before, but I'll teach it like you haven't. It says, examples, expand and simplify. Questions like this are unsatisfying. The answer you get doesn't feel like a final answer. It's not like solving equations. We'll get to that. We want to solve equations. That's what we're about, solving equations. But to be able to solve equations, we want to be able to simplify things first, tidy them up. Because this is a mess. No one would leave anything like this. Unless you worked at Samsung. Apple people don't do this. 2x squared plus 5x minus 7 plus 3x squared minus 2x plus 4. Do you see anything? What color will I use today? Oh, I don't know if I have pink. I'll use blue. Shirt's kind of blue. I'll figure out how to get pink on the screen. Oh, there's a purple. We go purple. Purple, purple. What do you see? Please tell me you see something that can happen here. Zoom. More zoom, she says. 200. Oh, the zoom worked good today. Was it yesterday that zoom was too much? What do you see in the list that I can simplify? Am I scaring you? Am I acting like there's some difficult thing to happen here? Like terms. Oh, that's all we're talking about today. Here, let's put that in brackets here. Adding and subtracting polynomials. We're just trying to find like terms and tidy things up. And for you future computer programmers, we're trying to make the code work faster so we can do less operations. So I like underlining. Because if there gets to be a lot of terms, which there will be eventually when you get to calculus, so just be a lot of terms. So don't just dismiss this idea that maybe we should keep track of all the terms in there. 2x squared and 3x squared. So if I got 2 xylophone squareds, whatever a xylophone squared is, and I got 3 xylophone squareds, I can put those together, and now I've got 5 xylophone squareds. It's not that mysterious. I'm acting like it's mysterious. What's an x squared? An x squared is, if that's an x, some unknown length, that's an x squared. It's just a square. That's why it's called squared. Maybe you knew that already, but it's important to know that all we're talking about is squares. So you can't combine squares with lines. They're different things. We can combine up the squares and say, how many squares do I have? I have 2 squares, and I have 3 more squares, so I have 5 squares. But x's are just one-dimensional. Huh? One-dimensional. I'm not being fancy. I'm really describing what's going on. We're talking about something that's one-dimensional. 5x minus 2x. So 5x minus 2x. Those can go together. 5 xylophones, subtract 2 xylophones, 3 xylophones. Mr. Todd, I don't like the pictures. And some people are like, as soon as they draw the pictures, like, oh, I get that now. Other people are like, don't do the pictures. Okay, I won't do the pictures. Let's say x was 10. These are hundreds. So I put the hundreds together. If x is 10, these are tens. I can put the tens together. So it's algebraically simple as well. They're different things, so I can combine them. I don't usually underline the last one, but some people like to underline the last one. -7 plus 4 is -3. Ooh, check that stuff. Here's the way your brain works. When you're juggling a lot of things, it's hard to do the simple things. For instance, I was at the Paris Fair, and they had the little mini circus there, and the guy was juggling 3 bowling pins. It was shocking. Because 3 bowling pins is pretty tough. But then he stood on a tightrope and put on his back foot a hula hoop, which he was waving around, and then juggled 3. That's hard to keep track of all that. And what's going to happen in your brain is, in the middle of this, you're like, okay, like terms. Mr. Todd said underline them, add them all up, and then you're going to see -7 plus 4, and you're going to write 3, or you're going to write 28 or something. Your brain knows what to do. It says, power on. Use all my strength right here. And then when it sees -7 plus 4, it goes, don't worry about it. I know how to do that. You're like, careful now. Don't trip on the finish line. Yeah, and take a second and maybe type those in just to make sure. Or right before you're handing your test in, you're just like, let's just check these. Because those are the most annoying marks, right? When you lose marks on something difficult, you're like, you can live with it. If you screw up negative 7 plus 4, you're going to be like, oh, you're going to do the full body. My 7-year-old does the full body objection. Have we talked about this? 7-year-olds, their whole body, they go like this. That's what you're going to be like when you get your test back. So check those. Type them in. Yeah? Even though, I know what this is. I'm really smart. I know. Be careful. Just be careful. Why is this one here then? Why do we need another one? Oh, this is 100 times more difficult. Look at this mess. Subtract. Subtract's the worst operation by far. I rank them in this order. Multiplication's the easiest one in life. Then addition. Then division. And then subtraction is just, it's like it's designed to trip you up because I'm subtracting all these terms. And you could handle it. You could do it like this. I don't suggest it. You could handle it by going, oh, that's 4m squared. And now I'm subtracting 7m squared. And then you go 5mn and subtract negative 2mn. But you see the problem that's going to happen? It's too many balls in the air. I like an extra step here. I got to tell you, I like an extra step here. I imagine that that negative is a negative 1. I don't have to imagine it. That's what the negative is. It's negative 1.
Oh, I know. Like, you can turn it into a positive and then flip the rest of them around. So you just flip it all around.
Yeah. 4m squared plus 5mn minus 3n squared. And I'll do exactly what he's saying. You got options here about how to write this. But I'm going to say, no, let's add, excuse me. And instead of subtracting, I'm going to add negative 7m squared, positive 2mn, and negative 8n squared. And after doing that, you're like, oh, everything's going to be all right now. Because that's the big trip up in this question. At that moment, that's when I'd order the pizza. I've never used that reference here before. Order the pizza means I'm going to be done my homework in just a second here. It's time to get a pizza. Yeah, you get it on the app, get it on the way because this is almost done. If you don't like what I just did there, you could also think of this as a negative 1 and distribute the negative 1. That was what I was about to do before he suggested something maybe better. His suggestion might be better than mine, but I was going to suggest distributing that negative. Don't underestimate negatives. In calculus, we have a saying, it's always a negative. It's always a negative. Do all this work and it screws up and we think we're stupid, and then you find out, oh, it's just a negative. We just screwed up on a negative, that's all. So watch the negatives. The negatives have to, as soon as you see that, let me highlight it in red. As soon as you see this question and it's got that negative, whoa, that's a giant highlighter. You're like, negative. Careful. Either way, once you've got that, hopefully things are better now. 4m squared, do my underlining, 4m squared plus negative 7m squared is negative 3m squared. And if you're out there thinking, I wouldn't mess that up, I'll be fine, you're the one that's going to mess this up. You should be scared of negatives. I'm scared of negatives. And if I can be scared of them, you should be too and go, well, let's just take a second here. Then 5mn's plus 2mn's is 7mn's. That's the one people are going to get wrong. They're going to see 5 minus negative 2, and they're going to write 3. If it happens to you, don't panic. Don't, oh, I'm not going to university. My mom's going to kill me. Settle down and just add another step in your thinking with the negatives. And then finally, negative 3n squared plus negative 8n squared. Oh, I can't resist having some fun on a Friday. I'm going to write down a wrong answer, okay? And then I need someone to explain why it's wrong, because it's a big problem. We explain stuff in math weird sometimes. This is a big problem. Ready? Wrong answer coming in red. Don't even copy it down. Negative 3 plus negative 8. 2 negatives make a positive.
No.
Plus 11n squared. Go ahead. Tell me.
It's negative plus a negative. It's not negative minus a negative or whatever.
Yeah, right. I like the or whatever he put on there. The or whatever sort of like, yeah, I know about the 2 negatives make a positive, but that shouldn't travel by itself. 2 negatives make a positive should never travel by itself. You should never say that out loud without saying 2 negatives make a positive when multiplying, when dividing, when subtracting, sometimes, depending on how you think about it. But not when adding. How do you think about this? Hopefully you have enough science background. 3 electrons and 8 more electrons That's lots of electrons. That's lots of negativity. This is negative 11n squared because you're taking negative 3 and you're adding more negative onto it. Ms. Todd, I don't like your pictures, by the way. But if I want to like your pictures, you've got to explain this. Mn. I get this. X is some length. X squared is some area. So what's Mn when the two lengths are different? What shape would that be? Not part of today's lesson, by the way. This is just me going, oh, wait. Trying to give you a chance to go, math really confuses me. And then I say a few things like, oh, wait a minute. I get it now. What would it be? It's a rectangle. Mn would be just like something like this. I don't know what the lengths are. This question doesn't tell me, but Mn is we're just talking about some kind of rectangle. So you see, I can't put the rectangles with the squares. They're different shapes. That's why the like terms situation. That might not be how it was explained before. The basic version of that explanation is usually a lot simpler than that. They don't have the same exponents and the same variables, so they can't go together. And you're like, oh, okay. And you just follow along and you play along. But there's a reason for that. These are squares, these are rectangles, and these are lines. Yeah? These are constants. We know what those are. Right. Any questions there? Only 5 pages to do today. Not 5 of your pages, 5 of my pages. Yeah? If your brain is done. I don't see a lot of snacks out there. I see the water. Where are your snacks? Bring your snacks. Your brain needs it. You've driven a car before, right? No. E, F, well, you've been in a car before. E, F. Yes, if you let it go all the way to E, have you been in a car that's done this? Or driven a lawnmower that does this? First it starts to go like that. That's what your brain will start to do. You're like, 7 plus 3. 9, you know? Oh, you didn't eat anything. And for those of you who didn't eat any breakfast, you got no chance. You got no chance of being what you can be if you're not going to go breakfast and lunch. It's not about me harassing you and going, I'll eat a good breakfast. No, it's about, hey, if we want to have brain power all day, you got to eat all day. All right? Or you can just be like me. No, it's easy for me. I love teaching, so I can activate using that. So you make sure you've got food. Do you need more time here? Do you have questions? Add, subtract, and multiply. We've added and subtracted already. Multiplying polynomials. All this is doing is combining distribution, which we talked about, with exponent laws, which we talked about. We just got to do it all at once. It's difficult. It's difficult. It's like the cat in the... Did we do the cat in the hat? Here's you doing this algebra. Hello, cat in the hat. Dee-dee, dee-dee. There he is. That's you doing algebra. That's what you feel like. I hope that makes you feel better. Like, whenever I'm doing algebra, I feel like I'm balancing 1,000 things. Yeah. Oh, okay. Yeah. But look at the smile on his face and the song in his heart. That's what you need now. We're going to proceed. We can't go on trudging through math. We got to be like, okay, what do we got here? Slow it down. I'm talking to me, not you. Slow it down. Draw the arrow. 2x times 3x squared. First, I need someone to tell me what the answer is when I go 2x times 3x squared. Then I need some explanation for somebody who doesn't really know. So what is the answer? It's 6x to the power of 3. Now, are you prepared to try to explain that to someone who's looking at that going, I don't get it.
There's like the exponent laws where you're multiplying, you just add the exponent.
Okay, so he's dealing with the exponents first. I think a lot of people do that. They go, I don't know what the 2 and the 3, but x times x squared, that has exponent 1, that has exponent 2. I'm adding the exponents. So when they have the same base, we just add the exponent. What about 2 and 3, though? You're just multiplying them. That's supposed to be easy, but it won't be. Your brain's busy adding exponents, and you'll see the 2 and the 3, and you'll write 5. Because you're seeing 2 and 3, you're supposed to add them? No, no. We're multiplying things. And when we multiply numbers, we multiply the numbers. But when we're multiplying things with exponents, we add the exponents. That's not a trick. That was a shortcut to not having to write this out. What I mean by that is I could do it this way. I could go 2x times 3x squared is 2 times x times 3 times x times x. Then I'm going to reorder them. I'm going to say, okay, multiplication's friendly, so I'm going to change that to 2 times 3 times x times x times x. 2 times 3 get multiplied together to give 6. X times x is x cubed. See, it's just a shortcut. So don't be embarrassed. If every once in a while you got to go over here and go, just let me think about this for a second, and rebuild the exponent laws when you need to. How about this one? 2x times subtract 5x. Isn't that subtract 5? Is this subtract 5x? Or is it negative 5x? It is now, right? When you first read it, it's subtract. When you go to multiply, now you think of it as negative 5x. So is it subtract or is it negative? Yes. It's whatever you need it to be. It's no problem. It's interchangeable when you need it to be. So 2x times negative 5x is negative 10x squared because it's x times x. It's just an area. Oh, hold on, stop. Stop. I liked your picture. I was starting to like your pictures. X squared, xy is like a rectangle, x cubed. What is that? It's a cube. That's why we call it cubed. X, it's x cubed. It's little cubes. So I can't add those together with the squares. Cubes and squares are different things. All right, smarty pants, what's x to the fourth then? Trouble. That's what that is. Yeah? Question, comment, adding. What's happening?
Oh, it's just like 2 times 2, but then you gotta add the x. It's like,
Yeah, because it's 2x times 2, so it's 2 times 2 times x. You're just going, which way can I multiply this to make my life easy? 2 times 2 times x. Right. Oh, look at this mother. Okay. Ooh, can you say mother on a video? I can if you don't let your mother watch the videos. Jeez. Here, you try. Well, let's not wait till tonight to find out you're terrible at these. Let's find out you're terrible now, and let's talk about it. You try this one, and I'll give a little hint here. It's probably going to take 2 steps. Yeah, you try that. I'll do attendance. If I stare at you awkwardly, it's because I'm trying to memorize names. Izzy, Emma, Sydney. Oh, new. It's okay. I'll think about it because I knew you were coming. Reese. It's the perfect last name for you, isn't it? I can't be the first one who's mentioned this. No. Oh, wait, some of you moved around? We've had some moving.
I love how she stares at me like as if I'm the only one.
No, I'm not. I'm looking back.
Not specifically when you were making eye contact.
Did she give you the accusation eyes? Did you do that?
No.
Yes.
Oh, Mrs. Todd. You've been in Mrs. Todd's class? She's great at the accusation eyes. She just stares at you and you're like, I'm sorry. You don't even know what happened, but you're already sorry. Sorry, Mrs. Todd, that you're on the video. Marley? That's a great name. Such a good name. Danielle. You're Ben. I know that somehow. Baseball.
Yeah.
Okay, good. Wait. Adele. Ice cream. I refused to ask. I'm like, what was it?
I'm sorry if I don't know either names. I know some of your siblings already work at night.
Well, I knew, but I didn't know. Like, I was sort of like, something about the summer in Paris. Do you live in Paris? Harry, Cameron, Fennel. Zora, I'm so glad you stayed, Zora. I'm so glad you stayed, Zora. Well, Adrian moved back. Dion moved way over. Okay, I got it. I think I get it. Okay, Harry. Oh, I already did those. I think I did it all. Okay. Who wants a shot at the whole first line? They can zip it right across. And the reason I'm getting someone to zip across the line is not to make you feel bad if you couldn't zip across the line. It's just to encourage you that if this homework takes you forever tonight and this weekend, it won't take you forever long term. You'll get to the point where you can just zip across the line. So don't panic just yet. You're like, oh, I'm never going to get good at this. No, that's not the way it happens. It starts to fall into place. Dion, you're taking a shot at the whole line?
Yeah.
Go.
3x times 4x is 12x squared.
Yeah.
3x times negative 5 is 15x, negative 15x.
Good. Yeah.
Negative 4x times x equals negative 4x squared.
Yeah.
Negative 4x minus 6 equals negative 24x.
Yeah.
3 times 2x equals 6x, and 3 times negative 4 is negative 12.
If you missed a negative, don't be too hard on yourself. Like, don't get too upset. Like, okay, I got to manage those negatives. That happens all the time. Come and take calculus with me next year, and we'll be like, in the middle of a question, you'll be like, oh, I forgot the negative. Happens all the time. That's a pretty standard error not to get too upset about. I better draw these in for you. If you're having trouble remembering to multiply that number by the second term, you might want to draw the arrows for a while until you start remembering. Did you go another step? Who went another step? Yeah, collect like terms. So, what'd you get?
12x squared minus 4x squared
Mm-hmm.
minus 15x minus 24x plus 6x minus 12.
Do you hear what she's saying? She's like, she might be doing something better than my underlining. She's like, no, actually organize them. That tool will come back to haunt you. You're like, I don't have to do that. When the algebra gets tougher, you might want to actually go 12x squared minus 4x squared minus 15x minus 24x plus 6x minus 12. Now, hold on. Did you see the best moment of the day just happened? You might have missed it. Did you see me stop for a second and go, I got a little confused by all the numbers and letters that were going by. Happens. You see me do it, you're like, oh, that's okay when that happens. That's the way algebra is. Yeah. Did you write this line like this? I like it. And then what did you get in the last line?
8x squared minus 33x
Minus 33x, yes?
minus 12.
Minus 12. Why are we doing this? Because once we get good at it, we'll do that, and then we'll do something else with this. I promise. Then we'll do some real math on this. We'll actually achieve something with this. But for now, we're just learning to collect like terms. If you're somebody who's hard on yourself when you get one wrong, that's fine. I guess I can live with that. When you get one wrong, you look at it and you're like, oh, I'm so stupid. I hate this math. Okay, I don't like that. But if you're like that, then you at least have to celebrate when you get one right. That's good life advice. If you're a negative person, okay, I don't like that. I hope you can do better. But if you're going to be negative, then you also have to be positive when things go right. You'll find out life's a lot better than you think. Yes? It's as easy as you go out and start your car and it won't start. You're like, oh, my stupid car, my life, I hate my life. If you're going to do that, that's fine. But then every time you go out and start your car for the rest of your life, go, it started. And you'll realize it's okay. Everything's okay. Yeah? So keep score if you want to keep score. Questions here, though? On we go. That was multiplying polynomials by monomials. I don't really care about the title. I'm not going to have a question on my test like, is this a polynomial or is it a monomial? These are important concepts, but I just want to address the title so you know what's going on. This is a monomial. One. Mono means one. The disease mononucleosis. One. Yeah? Polynomial means anything, any number of terms inside the brackets. Okay? So that's what polynomial means, is any number. Yeah? Ooh, nested brackets. Ooh, really scary. Use your thumb on these ones when it bothers you. Just go, oh, that's really confusing to me. But if you put your thumb on the 5, suddenly it's not that confusing. There's the same question we just did, actually. So try to ignore that. And do you see the square brackets? You might not have saw square brackets in grade 10. Square brackets are really handy for this situation, and I'll exaggerate it here. I'll make the size ridiculous so you can see why we're using square brackets. Watch this. Here we go. Equals 2 square bracket I love moves like this. That's what's going on. I did nothing in that line except accentuate what the square brackets are trying to accomplish for you, is to go, there's a set of square brackets. They're not any different than regular brackets. They're just helping you get organized. And then this is the stuff that I'm dealing with inside. You future computer programmers, Java and all those things will do this for you automatically. They'll make big brackets, then little brackets. You'll actually see it do it for you to help you get organized. Your calculator doesn't do it, so you got to count brackets. It's a nightmare. Okay, if the last question was easy, then the inside of these brackets should be pretty easy. I'll put the arrows on there, and I get 6x plus 9. And negative 2 times each of these, which is negative 2x plus 2. You're totally allowed to expand now. I could multiply by the 2. I don't suggest it. Simplify as you go. So I'm going to simplify this up. And I'm going to use my new trick. You do not have to do that step, but I put it in there to help you get organized, to go, ooh, let's put the terms together that go together. And then inside here is 4x plus 11. Done? Not quite. Now distribute the 2 when it's all over. 8x plus 22. Because I distributed the 2 at the end. Now, if your brain fuzzed out there a little bit, it's not time to panic. It's hard to let your brain focus on these things. And on your page, doing stuff like that can really help, and just cover something up and go, this is really complicated. Yeah, it is. So cover something up and just look at the inner part for a little while. But don't let me carry on. Make me earn this money they pay for me if you have questions there. Right there, tell me, is there a problem with those steps that you want to talk about? A concern? Ben? You can, but it starts down a path that may bother some people. It might not bother you. So I'll do it your way. Okay, so I'll switch over to, not red, I'll switch over to blue, a different color over here. It doesn't look different color to you, does it? How about, I'll switch to blue. No, I did blue. Purple, blue, I need something else. Black, hopefully it'll look a bit different. Here's a different way to do the question. I could have distributed the 2 right off the hop, but something's going to happen that might bother you. And that's why I usually tell people to do the inside first, is I multiply by the 2, and what I get is 6 times 2x plus 3 minus 4 times x minus 1. And that can really bother people, that I distributed the 2 only onto the multiplier. They're like, don't you have to put it in the brackets inside? And I'm like, yeah, I'm going to. I've still got to do that. So the 2 is still going to have that effect. But that set of steps, for some people, is fraught with peril. Yeah? So the 2 now got distributed to each set of brackets. I'm going to finish distributing it now to each set of brackets. And then when I collect like terms, yeah? but there's this one little potential danger there that it's going to bother you, and you're going to think that you got to distribute that 2 all the way through when you can't. You got to only distribute it to the multiplier, and then in the next step, distribute it out. Good? Great question. Other questions? That was page 3 of 5. 2 more to go. We okay? Some of you are dragging a little bit. Get snacks. Did any of you have snacks and then come here? Oh, some of you did that. All right. Multiplying binomials by binomials. Oh, I can't resist getting distracted for a second. My kids aren't ready yet for it. My kids are not ready for this yet. But I'm on my way to teaching them how to do this in their head. Just because I think it's fun. Because it can be done in your head if you know what to do. Here's what you do. We talked about this distribution thing the other day. We said, oh, don't use 12, because 12 is too hard to multiply in your head. Maybe your teacher forced you to memorize your 12 times tables. I wouldn't do it if I was a teacher. I'd end at 10 times 10. It's a great place to end. Feels great. And anything above 10, I'd do this. I break 12 into 10 and 2. This really closely relates to all that x squared and mn stuff I was talking about, by the way. Like, we're really close to tying those two things together. And then 35, I'd make it 30 and 5. Is this easy to do in your head? Well, I don't know. I can do it. 12 times 35 is 350, 410, 420. Yeah? All I'm doing is this in my head. This is all I'm doing. 350, 60, and another 10. That's all I'm doing in my head is each of those pieces. It's not as bad as you think. I can't do it. Well, you didn't even try it. Get good at single times double first. Yeah? You don't start off by doing that and go, it's too hard. No, it's not. It's pretty easy, actually. You start off with one of these. You learn to solve that. You get one size bigger, one size bigger. Actually, you shouldn't even be surprised. If I'm 50, I should be able to do this. Yeah? Because I've been moving my way up. So don't start to try to do these in your head. It's not even what I'm trying to teach today. Get focused. If we divide this into 2 numbers, and this into 2 numbers, we can do distribution, except it's double distribution. The 10 has to multiply by the 30 and by the 5. The 2 has to multiply by the 30 and the 5. And then add them all up. That's what's going on here. The 3x has to get multiplied by the 2x. It also has to get multiplied by the negative 5. The 4 has to get multiplied by the 2x. And the 4 has to get multiplied by the negative 5. All of those things have to happen. How am I going to remember to do all that stuff? Well, we could make an acronym to help. You multiply the first 2 terms together. Yeah, there is an acronym to help. FOIL. I like FOIL. I don't love FOIL. Because on the next page, I've got a question that might challenge your FOIL. It might unfoil your FOIL. Anyways, you must have seen this. You're supposed to have done this like crazy in grade 10. Forward foiling, backwards factoring, FOIL factor. Felt like your whole life was just FOIL and factor. Yeah? But I pause for questions. I'm not trying to rush things. If this was the moment, oh, this is the part I have trouble with, I want to talk about it. I want to earn my $27 they're paying me today or whatever it is. Is it okay? After FOIL, there almost always is a final step of combining the middle 2 like terms. We also do the opposite of this, going from this to this. What's it called when I go the other way? The one time you can use an F word in math class? Factor. And I know you love factoring. You're going to love factoring. I'll fix it. We'll get factoring down pat. It's coming up. Coming soon to a math class near you. The coefficient out front causes problems. And Ben asked about the other one. Can I do it in a different order? And the answer is yes. We could multiply the 3 in. I don't suggest it. When this situation happens, I think most people find it easier to go, I'll deal with the 3 at the end. I'll do the FOIL, and then I'll multiply by 3. So what I end up with here is 3, and then the FOIL. X squared plus 2x minus 4x minus 8. Then negative 2, then the FOIL. Okay, just to make sure, take a second, try and FOIL that second one, and make sure that you are as good at FOIL as you're acting. Did you already have this, or did you order the blue? You already had the blue. Trying to see if anyone got brave and ordered the pink one. Pink pencil case. No pink Casio. I'm going to write it so you can check your answer. I'm really hoping that most people can FOIL. If you can, it's not panic time. It's not, oh, I better go take a different course. I can't even FOIL. No, just FOIL. Yeah? Well, let's look at my phone. FOIL videos. I can't even FOIL, so I type in FOIL video. Am I going to get math? Oh, algebra. Algebra. FOIL video math. Okay, that's good. Oh, yeah. 700 different nerds think they can tell you how to FOIL. Like, come on. You can go home tonight, take a deep breath, and go, oh, I'm not good at FOILing. Oh, I'll FOIL. Or, senior math help. I'm there in 2076 every day at lunch. You come and I say, okay, got to talk about FOIL. Let's fix the FOIL, and then we can carry on. But I still got a number out front of each of these brackets. Can you do it now? You can. I don't. I like tidying up the brackets before. I want less to deal with. So I simplify things first. I go, okay, collect up the like terms. Then do the distribution. I know what some of you are up against this weekend. You're going to go through this algebra, and every question's going to take forever. And you're going to be like, you're going to be saying a different F word in front of my name. Mr. Todd, it's killing me already. I promise it'll get better. You start practicing it, and if you just stay at it, you don't get distracted every 2 minutes by Netflix. If you just keep practicing, eventually you go, oh, wait, I am getting faster. It's going to be okay. Yeah? But it only comes with practice. That's why you got to do all the homework. And then you get faster, and then you'll be like, oh, this isn't so bad once I get better at it. Can anyone zip through this line? Just ring the terms off quick. And I don't say it to show off. I say it to go, oh, if I practice, this can go this quickly. Who can rhyme off the terms here? Go, rhyme them off.
3x squared, negative 6x, and then negative 24.
Mm-hmm.
Next one.
Mm-hmm.
Negative 2x squared, negative 4x, and then positive 30.
Did you hear what he said? Positive 30. Good. I like it. Yeah, he thought it out perfectly because he thought for a second it was negative, then he did positive. Can you keep bringing them off? Again, I'm not saying it to show off with his skills. I'm showing it to go, when this weekend you're doing the homework and it's taking forever, relax, keep practicing, and you'll get to the point where you can just ring them off. It does fall into place. Mr. Todd, you don't know. I struggle with this stuff. You just got to practice. You just practice. It'll get better.
You gotta collect them terms, so like, do you want me to like solve it or like collect them terms?
Whatever you do.
Okay, then just 3x squared. No, I mean 1x squared, my bad.
Yep.
And then it would be negative 10x and then it would be, that looks like 6. I know, Dion. So I see a second.
That's the way algebra sounds too. Stop doing algebra on your own. Invite a friend over, do algebra, yell at each other. Come to calculus class, you should hear them yell at each other. It's good stuff. We'll get it figured out, right? Miss Ty, you're not supposed to have a 1 there. Doesn't matter, actually. It's okay. It's not against the rules. We just usually get lazy and don't put it there. Yeah?
Would it? No, that won't work. What if you like times or like added the 3 and the -2 just to like, and then you just times that by like all the.
Can't. And here's the reason you can't. This stuff is not the same as this stuff. So you can only put things together that are the same stuff. So you wouldn't go like this. You wouldn't go 3a minus 2b. You wouldn't go, oh, that's 1a minus b, because they're different. This a is different than this b. They're different stuff. So what's in this bracket is different than what's in this bracket. So I can't just add them yet. You can only add things that are the same stuff. Yeah, good. Questions? Miss Ty, you said you didn't like FOIL. I think I like FOIL. What's your problem with FOIL? That.
That's 3.
Yeah. Now there's 3 in this and 3 in this. And suddenly FOIL is only a guide. Yeah? You got to do a FOIL type thing. It's bad. It's bad. I told you it was going to get bad. Didn't I tell you it was going to get bad? It's whammo, 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 whammo. Don't even have any space to do it. So you're going to have to pick up your game and be a little better at it. Now the problem with math lessons like this is I'm asking you to pick up your game now. In a perfect world, what would happen now is I'd get you to do 2/3 of your homework right now. From 11 till 12. And at 12 o'clock, I'd do this example. After you've done a bunch of FOIL and got better practice, you'd be better prepared to deal with this 3x3 FOIL. That's not what it's technically called, but now it's just called a distribution, this massive distribution. And then you'd be like, after practicing your FOIL, you'd see better. So that's why the video is nice. So if this part is a little bit too much for you, no problem. Do 2/3 of the homework. As soon as you get to a triple FOIL like that, go fast forward through the video. Let's see what Mr. Todd had to say about this, and get ready for it. Okay? But we're under the constraints. You don't want to stay here for the next 2 hours, probably. Yeah, so we'll try this out, and at least it's in the back of your brain for when you run into the homework. Did you see what I did there? I didn't write the equal sign there. Maybe that's not a problem for you on your piece of paper, but sometimes you can see the algebra coming, and you're like, yes, probably not going to fit. Going to get myself some room. Before I start, though, how many terms are going to come out of this? 9. Each of the 3 terms is going to produce 3 terms. That gives me a guide, actually. I do them in 3s, me personally. So I'm going to exaggerate here, but I'm going to take a little breath between each group of 3 to keep myself organized. So x squared. Here comes distributing x squared. 3x to the 4th plus 4x cubed minus 5x squared. That helps me to make sure I get the right number of terms. I did that 3. Little break. Now the next 3, and I do use my thumb. Cover up this one. Now negative 2x all the way through. Negative 6x cubed, negative 8x squared, plus 10x. Little break. Now I'm doing them in 3s. 3, another 3, and then the last 3. Plus 9x squared, plus 12x, minus 15. See, I did them in 3s there. So that was a little bit too slow and a little bit too fast at the same time. I don't want you to miss the most important part of the lesson that I just did there. Do you see what happened there? I've done a million of these for a million years. And I still, after doing the line, look back and went, let's just check now. I don't want to do another line if something's wrong there. Question? Yes, ma'am. Can I choose the zoom? I want to do better zooming here. How about 300? How about 250? Is that good? Good stuff. Thank you for asking. Yes. This one? I'm not making fun of her. I'm making fun of my writing. Sometimes my writing gets a little... Mr. Todd, I can't do it. It's too much. I don't want to spend my weekend doing all this. You're ruining my youth. I'm not ruining your youth. I got news for you. Your youth is over.
Can I use the bathroom?
Yes. I'm just your guide to life. Going, oh, welcome. Your youth is over. Thank you. Thanks for dropping by. Here's what we're going to do next. Let's have a life next, will we? Shall we? I don't want you to be a loser your whole life. Yeah? I don't want to run into you when you're 30, working at asking me if I want fries. Yeah? Live in your parents' basement, playing Xbox 72, yelling at the stairs at your mom, is the craft dinner ready yet? We're getting our life together here. I'm not saying do math. I'm not saying do that. I'm saying if we're going to do something, let's do it. That's what I'm saying. It's about wanting things in life. This is supposed to be easy now. Is it easy?
Yes.
All right. It's not easy. Easier. This should be just collecting like terms type stuff. Question?
How did you FOIL it if it was the part?
Yeah, it's not. That's why I don't like FOIL. It's not called FOIL anymore. FOIL was a guide to distributing two things by two things. First, outside, inside, last. It doesn't work when there's more terms than that. Well, it does, but you need the idea now. The idea is x squared multiplies by each of those three terms. And negative 2x multiplies by each of those terms. And 3 multiplies by each of those terms. It might be as simple as this. Take a look at this group of 4 here. If everybody had to shake hands with everybody else, you had to meet everybody, how many introductions would we have? Yo!
Is Fife in class?
Yes.
Is she from Student Services?
Certainly.
Thanks.
Take a look at this. It really will help. How many introductions have to happen here? 1, 2, 3. Oh, no, she doesn't do the same one on her desk, right, for FOIL. 1, 2, 3, 4. 4 terms. That's FOIL. If we had to introduce everybody at this group of 3 to everyone at that group of 3, watch how many introductions has to happen. Ready? Him. 1, 2, 3. Then him. 1, 2, 3. Then him. 1, 2, 3. Now 9. FOIL doesn't. It's the idea of FOIL. So we sometimes say, oh, we got to FOIL these. Okay. Did that help? Okay, listen, a lot happened there while you weren't watching maybe. Some of the best things in this class happened just in that moment. Did you see me start snapping them with my fingers? That wasn't being dramatic. That's how I trigger my brain. Your brain's going to wander away. Your brain's like any other muscle. It's looking for a way to stop. So your brain, as you start doing one of these, you're like, oh, maybe I'd like to go play, what's the game on your phone? Clash of Clans. Maybe I want to go play Clash of Clans. Maybe I'd like to play chess on my phone. Maybe I'm going to go play my PS4. And your brain wanders away. Bring it back. Go, no, we're not going anywhere. We're staying right here. And that's what I have a trigger. Stop listening to them. Focus. And when you see me start to snap my fingers, I'm not doing it for your sake. I'm like, focus, focus, focus. Have something that brings you back to focus. Next, I did it all once, and you see me do it all a second time? I did it all once, and then I stopped, and I went. I checked it all. Here's what I left out. Underline the like terms. As you're going, ooh, this one needs another type of underlining. What will I use? I will use the star underlining, whatever. You know, you come up with your own system to organize those. My, what a mess. Check that one. Wow, you're trying the last one of the day. Is the last one of the day. How is this one a triple foil?
What you do is basically as scoring, you just like duplicate it.
Yeah. This is what you're going to have to do. So check my answer. Make sure you like my first answer. And then try this triple foil on your own. Let's not wait till Sunday night at 10:30. When should we do our homework for the weekend? Sundays at 10:30? Horrific choice. Now, it's in your stomach all weekend. Every fun thing, you go to the beach. Oh, I got that homework to do. You play Xbox with your friends. Oh, I got that homework to do. Do it Saturday morning. Do it Saturday morning. And by Saturday at noon, you're like, true freedom. Yeah? Try out this second one and see what you get, and then I'll share my answer in a second. Question?
Wouldn't it be like to the power of like, I thought it was like to the power of 2.
It is the power of 2. So,
No, yeah, but like, why do we have to like undo like the power, like duplicate it? Can't you just like do it in your head? Like,
can't you just square each one?
well, no, yeah, kind of. Like, no, like k, like 2 times, it's like 2 to the power, whatever that is. It'd be like you add it, so it's 4, and then 2k or whatever.
Yeah, you're
It's
tough.
like,
Because you're going to miss 2/3 of the terms. When it's adding and subtracting, earlier I said something like multiplication is my favorite operation. And I went addition lower than that. Addition's a problem. Once there's addition in here, you can't just square in there like you wish you could. It would be nice if you could do that. Does anyone have their question booklet? The chapter? Can I borrow this for just a second? Yeah. It's good. Multiply those out, and then we got to talk about, I don't know if you noticed what I just did. I skipped a lesson. On purpose. If you've tried it, take a look and I'll do my first line and you can compare with your first line and see how you did. there a fly buzzing around? You know what's going on here?
Yes.
It's flying right through the thing and freaking me out here.
Can you move that recording thing?
Yes, I can. See how long I stared at it after I finished it? Double check if it was right. How'd you do? If you made one little mistake or two little mistakes, yes, you can keep track of your errors in life if you want. But keep track of your successes here. There was 9 terms. If you got 2 of them wrong, like, oh, that's 7 or 9. It's not bad. So give yourself credit as well as blame if you're going to be that type of person. Questions?